Introduction to WAVE ScleraLens. In this video, we will talk about fitting a WAVE ScleraLens. There are 4 main steps to create a successful fitting WAVE ScleraLens. This presentation will go through each step in detail. The first step is to get a good topography. Then we need a good refraction. And in step 3, we will use the information from step 1 and 2 so we can design a lens and order it. And finally, once we have received the lens, we need a good lens evaluation to see whether we need to make any changes to the lens. Step 1. Since the WAVE software takes the topography reading and generates a computerized lens, thus it is crucial that the topography is as close to perfect as can be. With missing data and artifacts, we will extrapolate the data and generate a lens that is too steep or too flat for the eye. That's why when designing your initial lens, if you realize the topography scan is poor, then you should redo the topography to prevent unnecessary headache and excessive lens exchanges. For the best quality of scan, if the patient is a soft or hard lens wearer, we recommend them to be out of their lenses for at least 24 to 48 hours to get the best possible scan. If your Pentacam has the CSP software, depending on the model of the Pentacam, it can either be 5 separate scans or 1 to 2 scans. The criteria to look out for here is the QS value. A few yellow highlighted areas can still be acceptable if the values displayed is close to the acceptance criteria. Here we see the yellowed marked area is the 3D model deviation. It is very close to acceptable criteria. Therefore, this is a good scan. If any of the criteria shows up red, then it means it is beyond acceptance criteria, and the scan should be repeated to get a better baseline map. This is a very good CSP scan, where QS is good with no yellow or red markers. If the Pentacam you have does not have CSP function, then you can make a scleral lens by using only the central scan. Similar criteria for the scan. We want a good central scan with minimal data gaps. If the value is close to acceptance criteria, then it is okay. But try to get at least 2 to 3 good scans. If there are any red mark quality, then the scan is not acceptable to produce a good initial scleral lens. For the keratograph, there is no option to get a scleral data. Therefore, we need a very good central scan. The acceptable criteria minimum is about 6.5 millimeters of coverage with more than 65% of analyzed area. For regular corneas, it is highly recommended not to use a manually triggered topography. However, if the cornea is irregular, then the acceptable scan depends on the WAVE software and whether it is able to create a scleral lens based on the data taken. Using a viscous artificial tear can help when scanning an irregular cornea. If the only topography possible is manually triggered, then we should take 4 good scans to choose from to help decide the best scan to move forward with the lens design. So here we have a 7.4 millimeter vertical and an 8.4 millimeters horizontal, and with the analyzed area of 70%. So this is a good scan. For the Medmont, we want a minimal coverage of at least 8 millimeters when doing a central scan. Similar to the keratograph, for irregular corneas, the acceptable scans depend on the WAVE software as well, whether it is able to create a scleral lens based on the data taken here. And also here, we want to use a viscous eye drop to try to stabilize the tear film. However, you should also watch out for the lacrimal tear lake, as pulling of the lens in that area can cause an inaccurate reading. We want to have at least 4 good scans to choose from to help decide the best scan to move forward with the lens design. Medmont also has an option for a composite map. However, even with the best composite map, the data taken is only for the peripheral cornea, where the scans are stitched together. This does not provide us any sclera data. But composite maps can help us determine the corneal limbal junction and give us a better extrapolation data when the WAVE software reads it for the sclera. Step 2. It is important to get a good refraction for both regular and irregular corneas. We can do a subjective refraction to obtain the best visual acuity. For irregular corneas, we need a trial lens with an over-refraction. The reason we need to use a trial lens rather than just a subjective refraction on irregular corneas is because most of the time, these patients' irregularities diffract light and have multiple focal points compared to normal corneas. therefore making it hard to obtain an accurate refraction. If the patient came in with an existing RGP or scleral lens, as long as we know the base curve and the power in that lens, we can do an over-refraction and use that information for the lens design. If the base curve is unknown or the patient does not have a lens, you can use any trial lens and then obtain an over-refraction. Step 3. We'll take the data from step 1 and 2 and input it into the WAVE software to create an initial lens design. So let's go through how to design a lens using the CSP information. So here we have a base curve of 7.6, a lens power of -2, and then an over-refraction of a -5, -3 at 130. So let's design a lens via the CSP software. Since we have the trial lens data, we can input it into the power. The power here is referring to the power of the trial lens, and then the other boxes are for the trial lens over refraction. From the pentacam, usually the HBID is auto-populated from the horizontal white to white. So we can use that there, and then we can click X. We will choose the scleral lens, and then we can choose what we want for our lens diameter, which goes up to 18 millimeters, and the central clearance. We recommend usually 300 to 350 for initial lens design, but know that the lens can settle anywhere from 100 to 150 microns. You can choose to add a prism for the lens, but it will make the inferior edge of the lens a little bit thicker. We can see here that this is a good initial scleral lens design, and we are ready to order. When you are satisfied with the lens design, you should save first by clicking the Save button. When you're ready to order, you can click the Order button. Because we are designing in freeform, orientation of the lens is crucial. Thus, there will be either a dot or a line as the diagnostic marker on the lens. Now let's go through an example if we only have a central scan on the pentacam. This is similar to the Medmont or the Paradograph. Here we have a trial lens data of a base curve of 6.25, a lens power of a +5, and an over-refraction of a -15 sphere. To design a WAVE ScleraLens using the central scan is a very similar process. We can input all the data here, so the trial lens that we had, and then the power of the lens, and then the over-refraction. Then we can generate our ScleraLens template using the diameter and central clearance of choice. So here I want to use a 16.0 and 350. And then you can click Start Design. Because the scleral data is extrapolated, therefore you can see the tri-colored lines here on the edges of the lens. The lens is ready to be ordered. On the Medmont and the Paradograph, you will also see the tri-colored lines because both these topographers provide a central scan. Step 4. Once we have received the lens, we want to do a lens evaluation. The ABCDs of lens evaluation are rotation, fit of the lens, quality of the lens, and over-refraction. Rotation. We want to assess the lens after it has settled for about 4 to 6 hours. When we evaluate the lens, we want to make sure it is not decentered and the rotation of the diagnostic marker, whether it is a line or a dot, has to be at 6 o'clock. Because the lens is in freeform, if it is in the wrong rotation, the areas of clearance over the apex of the cone or area of interest can be different, and the edges of the lens may not line up as they should. For the purpose of seeing the diagnostic marker, here I have lined up the rotational marker to the nasal quadrant. So if the lens is rotated, we want to rotate the diagnostic marker using a cotton tip. Once the rotation is in place, we want to do a fit evaluation, an overview of the whole lens with and without fluorescein. We can use a few different methods to evaluate the fit. We can use the slit lamp, the OCT, or if you have a Paradograph, we can use that to get an overview, or you can use all three. Fit evaluation using the slit lamp. We can estimate the amount of clearance by comparing it to the thickness of the lens. If your lens center thickness is a 0.3, then at a 1:1 ratio, the lens will give 300 microns of clearance. You can use an optic section under white light, then determine the clearance centrally, limbally, and over the apex of the cone or your area of interest. This is a good slide from Ferris State University that briefly goes through what to look for when performing a slit lamp evaluation on a lens. We have the central vaulting, the limbal vaulting, and then the edge relationship with the sclera. Evaluation of the edge can also be seen using the cobalt filter. Assuming the rotation of the lens is in the correct position with the diagnostic marker at 6 o'clock, you can see that there is inferior edge lift here, and that the fluorescein is seeping out. However, if there is a bit of edge lift and the patient does not report fogging or discomfort from the feeling of the lens edge, then it can be an optional change. However, if we do want to steepen the edge, we can go back and modify our design, then click into Modification Tools and modify the alignment angle. We can increase the angle to steepen the edge at the desired location, which, assuming there is no rotation in this case, it would be at the 6 o'clock mark. The amount of microns chosen will depend on the degree of edge lift. Another way to evaluate the fit of the lens is using the anterior segment OCT. When performing this, the patient should be looking in central gaze because peripheral gazes can push the lens and give inaccurate readings. We would want a central scan and 4 peripheral scans showing the limbal clearance and the landing zone. The criteria for a peripheral scan is shown here. We want to see the edge of the lens and its relationship with the rest of the sclera and also the limbal zone. This can be used in conjunction with the slit lamp to get a very good idea of how the lens is sitting. It is recommended that this is done at the follow-up after 4 to 6 hours of lens settling. This is another way to look at the overall fit of the lens using the keratograph assessment. However, this has to be done in conjunction with either the OCT or the slit lamp evaluation. For irregular corneas such as keratoconus, pellucid marginal degeneration, grafts, etc., we want to scan the area of interest in addition to the aforementioned basic scans. This way, we can have a better idea of how much to change something if necessary. Next, we have the quality of the lens. We want to make sure there is no debris or protein deposits that can affect the quality of vision. Here we can see some deposits on the front surface of the lens. If this patient came back after 4 to 6 hours of wear, we don't want to remove the lens because we want to have an over-refraction with the settled lens design. So we can try to use the squeegee method using the back of a DMV to remove the protein deposits and then get the over-refraction. If the patient is able to take their lens off, we can physically massage the lens with a cleaner or treat it for 6 to 8 hours in clear care to remove the debris of the lens. But be careful not to use an alcohol-based cleaner if there's hydropeg on the lens, as that can strip the coating. And lastly, for the lens evaluation, we want an over-refraction. This should be done after the lens has settled. Let's go through an example. Assuming everything is good, perfect fit, good quality of the lens, and no rotation. All we have is an over-refraction of a -3, -1 at 90. So how do we fix that? This is how we add an over-refraction to our existing lens design. We click the ORX, and here we input our over-refraction, -3, and then -1, in our axis, and then because there is no rotation, we can keep that at 0, and we can click Apply here. When we change the prescription, we always want to check the center thickness of the lens before ordering. Here we see it decrease from a 0.3 to a 0.11. So we just change it back, and now the lens is ready to order.